Time feels constant, a steady river, flowing the same for everyone. But what if that's an illusion? What if time can stretch, slow down, or even collapse? More than 100 years ago, one man dared to say exactly that. His name was Albert Einstein. And what he discovered would change our understanding of reality forever. Before Einstein, the universe felt simple. Space and time were absolute. The great Isaac Newton believed time ticked forward at the same pace everywhere, like a universal clock that never wavered. Space was just a rigid stage, an unmoving background where all of life's events played out. Events happened inside it, but space itself never changed. For centuries, this idea worked perfectly. It explained the orbits of planets, the arc of a cannonball, everything we could see, until Einstein came along and asked a simple, dangerous question: what if space and time are not separate at all? In 1905, Einstein introduced his theory of special relativity, and with it, he shattered the old clockwork universe. He showed that time is not absolute, it depends on motion. The faster you move through space, the slower your time flows compared to someone standing still. If you took a trip to a distant star at near the speed of light, you might return having aged only a few years, while decades or even centuries would have passed on Earth. This was revolutionary, but it was only the beginning of his journey. 10 years later, in 1915, he went even further. Einstein published his masterpiece, the theory of general relativity. This was an idea so radical it seemed like science fiction. He proposed that gravity is not a force pulling objects together, as Newton had suggested. Instead, gravity is the bending and curving of space and time itself. The sun doesn't pull the Earth. The sun's immense mass warps the very fabric of spacetime around it, and the Earth is simply following that curve. As the famous physicist John Wheeler put it, mass tells spacetime how to curve, spacetime tells matter how to move. Imagine spacetime as a vast, flexible fabric, like a trampoline sheet stretched tight. Now, place a heavy bowling ball in the center. The fabric bends, it sags. If you roll a small marble nearby, it won't travel in a straight line. It will follow the curve created by the bowling ball, spiraling around it. That's how orbits work. Planets aren't being pulled by an invisible rope. They're rolling along the dips and curves in spacetime created by the sun. Now, imagine something far, far heavier than a bowling ball. Imagine a star many times more massive than our sun, collapsing under its own gravity at the end of its life. The fabric of spacetime doesn't just bend, it twists. It sinks into an impossibly deep well, pulling everything with it. This is what many scientists call Einstein's spacetime vortex, a whirlpool in the cosmic ocean. At the very heart of this vortex is one of the most mysterious objects in the universe, a black hole. Black holes are not cosmic vacuum cleaners, sucking up everything in their path. They are regions where the gravitational pull is so intense that spacetime has collapsed completely. The vortex becomes infinitely deep. At the center lies the singularity, a point of infinite density and infinite curvature, where our known laws of physics simply break down. The effects near a black hole are mind-bending. As you approach its edge, the event horizon, time itself slows down dramatically. An observer watching you from a safe distance would see you slow down, get dimmer, and eventually freeze at the edge, stretched across eternity. But for you, inside your own frame of reference, time would feel perfectly normal as you cross the point of no return. Einstein himself predicted this strange phenomenon. He personally didn't like the idea of black holes, they seemed too bizarre, but his equations were undeniable. They allowed for these cosmic monsters to exist. For decades, Einstein's wild ideas were questioned by many in the scientific community. They were just too strange, too extreme to be real. Bending space, slowing down time, it sounded more like fantasy than physics. But then, as our technology advanced, science finally caught up to his theories, and the proof started rolling in. Today, the GPS satellites orbiting our planet must constantly correct their internal clocks, because time for them runs slightly faster than it does for us down here on the ground, just as Einstein predicted. If they didn't account for this time dilation, your GPS would become inaccurate by several miles every single day. Then, in 2015, a century after he published his theory, scientists detected gravitational waves for the first time. These are ripples in the fabric of spacetime, created by the collision of two black holes over a billion light-years away. They were detected exactly as Einstein had predicted they would be, and perhaps the most stunning confirmation of all came in 2019. For the first time in history, humanity saw an image of a black hole shadow. Not a drawing, not a computer simulation. A real photograph of the glowing gas swirling around a supermassive spacetime vortex. Einstein was right, so why does any of this matter to you? This isn't just abstract physics for a classroom. It's the reality of the universe we live in. The fact that time flows differently on the ground than it does in orbit means that your phone's navigation system fundamentally depends on Einstein's work every single day. It proves that the universe you inhabit is not a static, boring stage. It is dynamic, it is alive, and in some corners, it is incredibly dangerous. Einstein showed us that reality itself is flexible, and in some ways, fragile. We are all living on a piece of spacetime that is constantly being bent, stretched, and rippled by the mass and energy all around us. Einstein once said, "The most incomprehensible thing about the universe is that it is comprehensible." His theories opened a door to understanding the cosmos on a level no one thought possible. Einstein's vortex is a powerful reminder that we are all travelers on curved spacetime, living inside a universe that is far stranger and more wonderful than we can possibly imagine. And the most exciting part, we've only just begun to understand it. If you want to explore the universe deeper and uncover more of its secrets, make sure to follow our channel. Because this is only the beginning of the journey. Thanks for watching.